attempt to run through this very quickly. We got a lot of slides to cover today, but that's okay. Please do not try to write down everything or take screenshots of this particular slide deck. There are, if you go into the chat, there will be a link to today's slides. So, you know, it's kind of a base thing in GIS where everyone's learning Python. So everyone wants to know, you know, or everyone says, I'm learning Python. That's the thing. Everyone's always learning Python. It's kind of a shame that I don't hear more often, I'm learning spatial SQL or I'm learning PostGIS. Because the question is, what can I do with PostGIS? I would assume that if you're here today listening to me speak, you want to know what exactly can I do with this software? What does open source bring to the table? And the answer is you can really do everything with it. It works a bit differently than your desktop software that you're familiar with. It's a little more programming, but you can do absolutely everything with it. That's because the OSGeo Foundation, which supports the FOSS4G conference, actually supports a number of core projects like Proj4, OpenJump, GDAL, QGIS, and PostGIS that are all interoperable and they all work together really, really well. So PostGIS, when we talk about PostGIS, PostGIS is actually running in the back end, Proj to do reprojection, GDAL to do data handling, and a couple of big open source GIS projects that are very mature and been around for about 10 years now. So PostGIS isn't just PostGIS. You actually get a large number of these projects when you install PostGIS locally. What do we mean by free? What does free and open source actually mean? Well, there's free as in beer, which is permissive free and open source software. And so really what makes a difference between these two is the licensing. So if you see something under a BSD, an Apache license, an MIT license, the Postgres license, which is modified MIT, or the CC0 or CC BY licenses, these are permissive FOSS licenses, and it's free as in free beer. You can do anything you want with this software. You can modify it, you can resell it, anything at all. There's also a segment of open source called copyleft, free and open source. That's free as in freedom. It's copyleft licenses are designed to preserve the intellectual environment of open source development, and so that's GPL, APGL, and CC by SA. Typically, these licenses require that if you make any modifications to the underlying program, you also must provide those modifications on request. So if you, say, work on something that's licensed under GPL and you create a plugin, the GPL licensing says that you have to make the source code of your plugin available. There are ways to commoditize both of these things or to commercialize both of these things, and many, many companies do. But companies tend to be a bit more comfortable with permissive FOSS. Most of the stuff that I'm talking today is under a permissive license, either MIT license or the Postgresql license. And when people often talk to me and they say, you know, why should I use open source or why do I want to? I say, well, you actually already are. There is actually, if you search for the legal acknowledgments on the internet, you will get a link to this enormous PDF that has 646 pages of open source license reprints. And down here at the very bottom of this thing, all the way at the bottom, there is a 100-page table that lists literally every single piece. Let's just go here. Of open source GIS that goes into Esri's platforms and what products they go into. And if you look down here in the middle license, you'll see that a lot of these things are licensed under permissive licenses like the ones that I just talked about, the BSD and the MIT. So you're already using open source in a big way. Most of Esri's products run on the back end the same exact software that you'll be seeing today. The interface is just different. Okay, so when we're talking about PostGIS, what are we talking about? We're talking about the main PostGIS extension to the PostGresql database software. So this is an extension for a enterprise relational database, and it gives you 275 plus functions for vector data, and that includes support for 2 coordinate system types, that's geometries, which are XY planar coordinate systems, and geographies, which are latitude, longitude, spherical coordinate systems. And there's support for 6 OGC vector geometry geographies, which are points, line strings, multi-line strings, polygons, multi-polygon geometry collections, and the 3D, 3DM, and 3D-ZM variants of all of the above. You also get the Shape2 PGSQL and PGSQL2 Shape command line tools that you can use for importing and exporting data. 8,500 coordinate systems plus the transformations that go along with them via the Proj4 project. And you can import a wide array of file types via the GDAL tools that come with this. And we'll talk about those some. You also get the PostGIS Topology Extension, which gives you face, edge, and node support. PostGIS Raster has 175 raster functions and support for about 5 or 6 dozen raster data types. PG Point Cloud for 3D LiDAR data, the address standardizer and Tiger geocoder for standardizing and geocoding addresses. PG routing and OSM2 PG routing are both involved in route finding using OpenStreetMap data or other street networks. And then OGR FDW, which is a extract, transform, load, and ETL tool that I will talk about in more detail towards the back end of this presentation. Postgres by itself also gives you native data types for date times, blobs, UUIDs, JSONs, JSONBs, network addresses, XML arrays, and ranges. You also get procedural language support, and this is, you might not realize what this means, but actually I believe it's PL Python 3U is a big deal for GIS, and I will show you why. And then you can actually layer REST services over this, just basically drop in with Postgres. This is largely based on the success of the Postgres project itself. PostGIS has been around now for about 20 years, I believe. Postgres has been along for about 5 or 10 years longer. It is one of the largest enterprise database platforms in the world, and lots and lots of big companies and big government organizations from NASA to Reddit and Airbnb use Postgres and PostGIS for their database server and their GIS computations. All right, so how does PostGIS compare to, say, another big name enterprise geodatabase or database system, RDBMS, like SQL Server? Well, it's got a lot more functionality. It can handle raster data. The big one for me is spatial transformations that you can project and reproject directly in the database itself. And I'll show you some neat features to go along with that. SQL Server 2012 had geography support. So that's for doing 3D spherical measurements using latitude and longitude. But I believe they later removed it, if I recall correctly, or if my information that I did on this is correct. But they will support geometries. And back last year, if you saw, or if you were at SHRUG, I did a presentation where I tested 3 identical test data sets across 3 different servers, which was a SQL Server 2012, a SQL Server 2018, and a Postgres PostGIS 2.2 database. And where I ran like 9 benchmarks across the 3 database servers using about 100,000 points, 3,000 coastline line segments, and 67 county test polygons. Basically, PostGIS absolutely beat the pants off SQL Server, both SQL Server 2018 and SQL Server 2012. It computed all 9 benchmarks in 4 minutes. It took the newest SQL Server installation that we had about 6 hours to do that, and it took the old SQL Server installation or instance about 24 hours to do the same set of benchmarks. So that's a massive leverage in terms of spatial computation. And a lot of that is because of how PostGIS works and how Postgres works, which we will get into very, very quickly. So I'm going to very quickly run over some background concepts and how GIS software works on your hardware. This is important for understanding why Postgres gives you a huge boost right out of the gate, or PostGIS gives you a huge boost right out of the gate. And then where you're going to hit bottlenecks as you think, oh man, this performance will scale. And there's some tricks to scaling GIS performance in Postgres that we'll talk about as well. All right, so essentially this process, when a user queries ArcMap or ArcPro, that query goes to the CPU unit. So the CPU unit starts a disk read where it reads the data off of the out of a file geodatabase or out of an enterprise database into your local RAM. Then it uses that data in local RAM to make a spatial query or computation and to calculate that. And then it'll return the query results to you. Now, once this process happens, this happens in two different ways for ArcMap and ArcPro. In ArcMap, that query results pass back to that single CPU unit for rendering, which is why ArcMap for years and years and years was absolutely terrible at rendering large data sets, and buying a bigger computer wouldn't help you. With ArcPro, the main difference between these two is that ArcPro actually taps the GPU for rendering. So GPU is your graphics processing unit, right? It's like an NVIDIA graphics card. And they're designed to render lots of points, lines, and polygons very, very quickly. So the major boost that ArcPro has gotten is involving the GPU in rendering. And this is why actually upgrading to a bigger computer will improve your performance substantially with ArcPro. Well, that and the fact that ArcPro is 64-bit and can actually use all of your RAM. Postgres works a bit differently. What we actually have is a client side and server side. So PostGIS, Postgres is our server side. And so when we query on our client side, typically in something like QGIS, although Postgres does work with ArcMap, there can be issues, particularly with polygons. But both ArcMap and ArcGIS or ArcPro have vastly improved their support for PostGIS in recent years. But when I give a query in QGIS, what it's going to do is it's going to pass that query over to Postgres. And Postgres is going to have its own set of cores and its own set of memory with which to do that disk read off the disk into RAM to do whatever spatial query or computation is in that query. And then it's going to pass that query back to QGIS for rendering. And the big deal with QGIS, and I will show you very quickly how to make substantial improvements in QGIS performance, is that QGIS has had 4 years multi-core rendering. So you can actually say, if you have 12 cores on your machine, you can actually give QGIS 6 or 8 of them just for rendering large data sets. So when you combine that, where you have QGIS has multiple cores on the front end, and PostGIS has multiple cores on the back end, so PostGIS is serving out data with multiple cores, QGIS is rendering that data with multiple cores, you get a massive performance boost in large vector data sets. And it seems kind of weird to say, but I have seen QGIS render, QGIS and PostGIS render the statewide cadastral data set of all, 11 million parcels in Florida within seconds, if you can give it enough cores and enough resources to do it. Whereas even ArcPro with an NVIDIA Quadro, I think P6000, was struggling. What's more impressive is because I have seen QGIS do this over remote desktop. It can render faster over remote desktop than my ArcPro can render locally. The kids know this, so one of the cool things about internet culture is that actually GIS people and the younger GIS kids are actually taking, a very big interest and a very big lead. So they make lots and lots of memes about how slow ArcMap is, and how difficult it is to work with raster data in ArcMap and stuff like that. And it's kind of cool because there's a large segment. I think Esri owns 50 to 60% of the desktop market, and so there's a large segment that will never step outside of Esri software. But if you want to do things beyond what Esri software can do, very quickly, very completely, and very free, Open source GIS has come an enormous distance in 10 years in terms of the capability and its usability. When I got into open source GIS about 15 years ago, it was truly nightmarish. But fair enough, ArcMap 8.3 was also fairly nightmarish as well. All right, so how do we install this? This is pretty easy. We're going to cover 2 steps: installing Postgres, creating a spatial database. All you do is you go to the Postgres webpage, go to download/Windows, click on the download the installer certified by EDB, download the version you want. Here's a pro tip: you usually want the latest version, LS1, for the long-term release for reliability. The only reason that you really should go outside of that rule is if you need cutting-edge features that simply aren't in the latest release of Postgres. Here I'm using Postgres 12 PostGIS version 3, which was just released a year or 2 ago. Yep. And just saw a major upgrade. So what they're working on now is leveraging Postgres has a lot of new features for parallel processing. And so now what they've really been focused on for version 3 of PostGIS is linking in PostGIS so that we can do parallel spatial computations. And it's getting better and better. More and more functions are becoming parallel in PostGIS. We just had a release version 3.1, I think, is coming up. All right, so why is Postgres sending you to EDB, who is a private company? Enterprise DB they provide technical support for enterprise PostgreSQL deployments. A lot of enterprise people get a little nervous about open source software because they're like, we don't have paid support. EDB is there for you. They will support your enterprise deployments. They have a wide array of enterprise tools for doing that. And you will get an installer from them through that link in the prior slide, an installer for Postgres, pgdump, and Stack Builder. So Stack Builder is what bundles the PostGIS extension in. You're just going to run the installer. That's going to give you, in the current version for Postgres 12, PostGIS 3.02, you get a nice listing of all the version, of all the tools that are in there. And so once you get it installed, you want to open up pgdump. You're going to set up the connection to your local host. This is how to do that. It's fairly easy. This is what the pgdump interface looks like. And basically, to create a spatial database, we do a couple of things. The first thing is we create a database. So we highlight our Postgres database. We click the new query button at number 2. We type in create database GIS, and we hit the go button, the play button, and that's going to create us a new database in Postgres. Once we have that database, we're going to highlight it. We're going to set a new query for that database inside that database, and we're going to say create extension PostGIS. And that's all you have to do. You'll see this message, boom. You now have a geospatial database in Postgres. What can I do for this, or do with this? Well, if you're a beginner, there's actually a lot of really nice functionality in here that's bundled in when you use PostGIS together with QGIS. And this would be a classic desktop install. So this would be like what you were used to with Pro or ArcMap, where all of your data and your software is on the same machine. Basically, same thing, go to QGIS, download the long-term release installer, and install it. Here's a pro tip for really improving QGIS performance in this case. Once you install QGIS, the first thing that you need to do, open Task Manager, figure out how many cores you have, and then go to the settings in QGIS and enable parallel rendering using around 1/4 to half of your cores that are available on your machine. You can find your cores in Task Manager. It will tell you logical processors down there to the right. So once we configure QGIS to run really quickly like the blazing wind, what we're going to do is add data. So this button here in QGIS is on your second toolbar is the Add Data button. You want to highlight Postgres in the left-hand window. A window will pop up, so you highlight Postgres. You hit New Connection. You name it whatever you want. And so you're going to put in these parameters, essentially. And you want to make sure that these two options down at the bottom are toggled. There's also list tables with no geometry, which will show you non-spatial tables. And you want to toggle saving and loading QGIS projects in the database. All right, that's all you got to do. You now have a database system that's set up and ready to receive data. You have a client software in the form of QGIS where you can open all sorts of spatial data. Go forth in GIS, go out to fgdl.org. For this one, I grabbed the Wakulla County 2-foot contours, which is a 355 megabyte geodatabase, 6 figures worth of contours, somewhere north of 100,000, so a lot of lines. And you want to open this in QGIS, upload it to PostGIS, and we'll show you how you can manage all of these layers. People think QGIS doesn't support databases. It does. It's a little different to find it. You hit your open data button. You want to highlight vector there on the left-hand side of that pane. You want to go to the directory option and set the type to open file GDB. And then you want to point it to the folder of your geodatabase. This stuff will drop right in. It'll give you a selection for all of your vector features inside your geodatabase. Then you go to your toolbox. You find the export to Postgres tool. And with this, you're going to export to your database server. You just pull the layer out of the TOC. You use the connection that you just set up. You can rename the schema and put it in a new schema. You can give it a new table name. All of this stuff usually leave as default. The thing that you always want to check is to create the spatial index, which is very important. And really cool, QGIS, the latest version, has a run as batch process where you can do this across a lot of files at once. This is a relatively new feature, and it's very, very nice if you're not comfortable with command line scripting. So watch this. This is pretty cool. So here is the those 2-foot contours from the geodatabase. If we open it up, we connect to our database server, our Postgres database server, after we've loaded in the data using the export to Postgres tool. Then what I do is down in my table of contents there on the bottom right, I right-click on it, I go to Style, Copy Symbology, and then I can go click on the other layer, right-click on it, hit Style, Paste Style Symbology, and just like that, we have transferred the style from one layer to the other. No esoteric import, it's right there in the menus. Like import symbology, it's right there in the menu. Style, copy style, style, paste style. So that's a really nice feature that I really wish Esri would catch up on in terms of usability. This is absolutely awesome. You can also, in the symbology menu, there's a little save button down there that you can go and hit save style. And you can actually save your styles for your layers in the PostGIS database with the layer. And it allows you to give you a description of the style, the things that you want to save, and you can actually set styles as default. So when you go back and you pull those in, QGIS already knows right away what the default styling for any layer in your database is. This is another fantastic option. You can, in your project menu, you can go and hit Save to PostgreSQL. And so you can store all of your layers, all of your projects, and all of your symbologies together in PostGIS when you're using QGIS. One location, one file format, which is the Postgres database, one easy interface, which is QGIS. This is just absolutely fantastic. In terms of portability, the ability to actually take that data and dump it out to a flat file and import it to other servers is just absolutely fantastic. Every map, project, and layer and symbol can all be stored together in one location instead of across 8 million directories. Neatly enough, in QGIS, this also works in geo packages the exact same way. So if you don't or can't install Postgres, you can still do this in QGIS. Geo packages are just SQLite databases. So here's a big question for you beginners. Do you have a group project, right? How many of you have tried to share a file database with a team on a network? Or you've locked yourself out of your own data on your local computer because you've got it open in ArcMap or ArcPro and ArcCatalog at the same time. Schema locks are, they're really annoying. Awesome thing about this is QGIS and PostGIS, when you work with them together, supports concurrent multi-user editing right out of the box. You can edit you can add your whole team and edit the same layer together. Transaction-based editing means that you won't have schema locks or anything like that. QGIS does have a database manager. One thing I'm going to note that's really nice, that's a Postgres function, but that has been really well integrated with QGIS and PostGIS, is the ability to comment anything in Postgres. So every table, every field can have a comment that goes with it that you can read right there in your database manager or in pgadmin, which makes it absolutely fantastic for doing calculations. You no longer have to worry about like, what the heck was this data for? You can just add a comment to the table, or what the heck was this column for? Just add a comment to the column. This has saved my bacon many, many times when I returned back to work that I did 2 or 3 years ago. And I want you to think about your teammates in terms of usability, right? The ones that use desktop GIS every 3 to 6 months to do 1 or 2 repetitive tasks. Like, how many times as a GIS professional, or how much time do you spend teaching them and reteaching them basic tasks in ArcPro and ArcGIS, right? Do you still manage symbol sets with layer files? Are you just pointing them to ArcGIS Online? You know, how many of your colleagues break their data paths in ArcMap or ArcPro? They don't know how that works, and then they need your help fixing it, right? So this is a way that you can set canonical copies of layers, styles, you can set projects, you put them all on a central database server. They're all accessible directly in your user's desktop software from the GUI, and it's all 100% free. And I've said for years, for people that just do basic viewing and editing in GIS that are non-GIS people, this system, QGIS, makes an enormous amount of sense compared to having to continually teach and reteach them how to work with Esri products and file geodatabases. Okay, so you've kind of like dipped your toes in here, you've set it up, you're playing with PostGIS, you're like, wow, I kind of like this. What are the things that I can do with it? Basically, intermediate PostGIS is all about PostgreSQL and learning how to effectively manage data and do things in a fully featured database environment, an enterprise database environment. So this stuff we're going to fly through. I'm not really going to cover a lot of it. There's going to be a lot of writing. That is for, you know, your later use if you want to go back and say, oh wait, how do I do this? This was in this presentation. So just, you know, listen to my voice, look at the pretty pictures, and ignore most of the text. So the first thing you want to do is start learning your Esri equivalent concepts that transfer between Esri and between PostGIS. So geodatabases are databases. Feature data sets are actually schemas. Feature classes would be a table or a view, right? Your toolbox and your tools, those are going to be your PostGIS functions, those 275 functions I talked about. And for rasters, those are actually backwards. Wow. Esri should be raster catalog, raster mosaics, and in PostGIS, you can actually set up in database or out of database registered rasters. And this is where you start to really see the power of this, because reprojecting data becomes not only easy, but very quick. So in this case, I want to reproject everything to WGS 84. So all I do is I added a column to the table that has a geometry with the EPS G code 4326. That's that first little block of code up here. And then to reproject, I just say update the table and set that column equal to, and you say SD transform your geometry column with your target projection code. That's all there is to it. It ran across all these contours. Yep, there we are, 235,000 contours were reprojected in a little under 2 minutes. You can create workspaces, which would be your schema. So I can just create a schema called SHRUG, which I'll be using for the rest of this tutorial in these code examples. And if I want to say create table shrug.contours all as select all from contours to foot color, that just create a new copy of the data. I can create subsets the same way with these create table statements, where if I want everything less than 10 feet, 16 seconds to do that, right? And when you start doing this stuff, you might actually find, wow, I thought this was going to be faster. Well, that's because you need to spatially index columns, which we'll talk more about in just a second. There's another trick here called clustering and geohashing that will organize your table rows by geography to make searching and finding on spatial queries faster. Here's a link to how that works and why. Not going to go into much detail, but this is basically what happens is on an unclustered table, all of the rows that are geographically close to each other are all over the place on the disk. When you cluster them together, it puts everything that is geographically close right there next to each other. So when you start doing intersects or buffers or whatever, it doesn't have to go all over looking for the data. It knows that everything that is close to each other on disk is going to be close geographically. So this makes a absolutely huge difference in your performance. This is a feature, geez, I wish Esri would add this, because with file geodatabases, you have to create a new copy of the layer every single time you want to reproject it, because file geodatabase layers can only have a single geometry column. In Postgres, you can have as many geometry columns as you want. You can have line strings, polygons, all this stuff, all in the same table. When you open it in PostGIS, it'll actually give you a choice. Here you see that the contours all layer, that I can choose the 3087 or 4326 geometry column. So right there, I can just select which geometries I want to display. I don't have to have 8 million copies of all of the geometry data plus the attribute data on disk. If you want to do something basic like finding links, right? This goes really, really quickly. So we add a table, we alter the table, we add a column. We're going to update the table, and we're going to set the new column to the result of the st-link function. That's one of those PostGIS functions that will give us the geographic length of the line. That ran across 37 seconds for that entire 200,000 row table of what color contours. Wow, okay, so this looks really great. How do I manage this? How do I start getting data in and out really efficiently? There's a whole suite of command line tools, and if you start getting into it this deep, you're going to become me. You're going to become a weirdo that like gabbles on about really obscure stuff that nobody cares about, as they panic and try to edge away from the crazy man. But just a couple of these that are really important here. OGR info, OGR2, or ogre to ogre. These are GDAL file type conversion tools, which you'll see how we bootstrap those in just a couple of minutes. pgdump and pgdump all, pgrestore. These are how you back up and restore your data. So these are like a standard process for migrating databases to new servers, upgrading Postgres to a new major version, upgrading PostGIS. It's kind of slow for big data sets. There's some tips to speed it up. If you start using these command line tools, you're going to want to alter your path environment variables to make everything easier to call up in command lines. But these command line tools allow you very easily to like suck in entire directories of data. So they're very, very powerful, and they're very, very fast, because most of them are written in C. So once you get all this data in there, right, you start playing with these tools, and you have like all these standard symbols, and you have projects, and you have just layer after layer, you have computed layers and analyses you've done. Like, I really want to share this. How do I let other users access this? So this is where you want to get like spatial with friends, and you want to serve them out data from either your desktop, or in some cases, if you want to run like a bootleg GIS server inside your network security, and you have an old machine that you've installed PostGIS on, what you want to do is you want to tell Postgres to actually listen for connections. Postgres has very conservative defaults. By default, it does not accept outside connection requests. And it also has a very tiny memory footprint. This is so you can install it on virtual machines that have like a gig of memory, and Postgres will still run happily out of the box. So we want to do two things. We want to alter pghva.conf, which will open up Postgres to outside connections. And then later we'll see where we change some memory configuration in the Postgres. So the cool things about these configuration files is they're all text files. They're plain text. So you just go in them and you Control F, you find what you need to change, you change it, you save it. If you have another server and you want to take the settings from one server and apply them so that your other server, your second server, is configured in the same way, it's just a matter of copying and pasting the text file. Always create a copy of this text file before you start modifying it. That becomes the backup. But this becomes very easy to like hold multiple configurations right there next to each other as text files and just load them in. So here's how you will allow outside external connections. This is an explainer. GIS people do not do networking security. this is the fundamentals of networking security and how it works. But it's at its most basic level, the most secure system is one that will not talk to anybody but you. It will not respond to any request but your IP address. So that's all how to set that up. Once Postgres is accepting outside connections, you can set up different users with different permissions. So you can set up read-only users. You can set up editable users. All of this is in very plain SQL language, very easy to read, very easy to understand what's going on. You know, you want to grant, connect, own database SHRUG to SHRUG reader. That gives the SHRUG user or SHRUG reader user the ability to connect to the database. And you want to grant own all tables, whatever. So that's all privileges. You can also set ownership. Owners are like their own little, they can do anything. They can delete, modify, update data. So it's just granular permissions. How do we go faster? Well, we go back to postgres.conf. We're going to go look for these things in the file. You want to upgrade them. This will make sure that Postgres starts using more cores and more memory to do spatial computation. This is really cool because most of the major cloud services support PostGIS as a relational database service. What's an RDS service? It is a serverless database. All you get is an endpoint. You have nothing to manage but the connections. It's available in minutes. They typically run around $500 to $100 per month for small spatial databases, increasing with the size of your data. It's available all your major providers. You have PostGIS right out of the box. This is convenient. You can schedule backups and do all sorts of stuff that's harder to do if you actually have to manage the software-only server. You can set up GeoServer here off an RDS instance, and you can serve out a lot of imagery very, very quickly. Vector data is more problematic because you'll learn about the horror show that is SLD styling. Shows that I have 5 minutes left, I believe, or should be coming up close. So we are going to very quickly run through this, the rest of this stuff. Ooh. All right, so this is advanced PostGIS, which is all about spatial SQL. This will be your new best friend. This is written by the founder of the PostGIS project called PostGIS in Action. It is about how to do all sorts of cool spatial stuff with spatial SQL. OpenJump is a Java program. It's very, very nice. It's very, very lightweight. It will run off a thumb drive, which makes your GIS very portable. With different documentation links. So this is an example of working in OpenJump with spatial SQL. So this is actually using PostGIS to do computation. When you're just connecting the stuff with QGIS, you're actually doing all your computation in QGIS. And so this will just show you how this actually works. These data store queries actually allow me to live query the database, and it reads it into memory in OpenJump on my local. So I can actually work through query development. I get this very nice pane where I can see every query that I've sent. And I can actually develop more and more complex queries that go and look at certain things. In this case, I was looking for closed topographic depressions in these well-colored contours. There's a data problem where some of these line strings aren't actually merged together. This is roughly what the solution looks like. This took me a little bit of playing with to develop, but it ran very quickly once I got it. And so basically what this is showing you is that these are all of the topographic depressions, the closed topographic depressions that should have been a single line string that were multiple line strings in the Esri data. So there's your final solution is what it looks like. The very nice thing is that I can take this code and apply it to other tables of the same sorts of stuff. So working with PostGIS at this level is all about working in harmony with Postgres. You want to start learning about how Postgres actually works. It's actually a little bit different than something like SQL Server. You have sub-processes. This actually prevents memory errors in one thread from overwhelming the server and crashing it. If this process dies, the master Postgres process just kills it. So this is why Postgres works with so little memory, and it's all about indexing. You actually need to index. The index allows you to set up very, very fast queries, but working with the query planner and the indexer is where you start getting really, really fast spatial queries. And so indexes plus a little knowledge, you actually equals magic flying trains, which I'm not going to get a chance to talk about, sadly, but that's fine. So here's some advanced resources. And then enterprise PostGIS, at this point, you're like creating these Ubuntu PostGIS servers as virtual machines on your local work laptop for every single job that you have, because what you're doing is you're using PostGIS to import stuff from Oracle, SQL Server, access CSV data, and you're sucking it all into a Postgres database and doing some spatial processing. So OGR FDW is a really nice extension for Postgres that allows me to read in foreign tables. So here, this is showing you I've connected to a SQL Server and I've read 99 tables directly in to PostGIS with this example. And then also with Python 3U, I can write Python functions that Postgres can run. Why would you want to do something like this? So this is an example of a Python strip function that's stripping text of whitespace. So remember the pgdump and pgrestore, where we dump out all of the data in the database and restore it to a new server? Your Python ETL code, so anything that goes out and finds data and reads it into the database, now stays with your data too. So there's your symbols, your projects, your layers, and all of the code, and it's all in one database together, and it's just incredibly powerful and convenient. Here are you some links here, some pro tips for running it. This is going to conclude my talking portion. If you want to learn more about Spatial SQL and PostGIS together, there should be an event on Eventbrite open today. We had an open source GIS interest group last year that was really successful. We're going to try to do the same thing again next year. So starting January 6th, we're going to start working through PostGIS in Action by Regina Obe. We will meet the first and third Wednesday of every month and work together. And we will go. We will continue going until everybody quits, or we finish the book. So if you're interested in that, I've got room for 30 in my my Zoom meetings. So go sign up and you know, come have some beers and learn about being a better GIS analyst in Spatial SQL on Wednesday nights. Thank you.
Awesome. Thanks, Seth. That was great. We don't really have time for questions right now because we are almost maybe 30 seconds. Actually, we are a little over. Either way, though, appreciate you. And looking forward to seeing your next presentations.
Thank you very much. Thank you very much.
All right. See you.